Okay, so today we're going to learn about law of sines. And I've left you this video because I'm not here today. But at any point, if you need to stop and write things down, just press pause and then go on from there. So law of cosines is something we have seen before. You guys learned about it in geometry, and I'm going to have the formulas up on the wall for you, so don't panic about having to memorize this particular thing. So the law of cosines is the last piece of our triangle geometry toolkit. We already have SOHCAHTOA and its reciprocals, and then we have law of sines, but we need to know that there are opportunities, I should say, or situations where we need to use law of cosines. So in this triangle here, I have this angle A, so I'm going to call it angle A my reference angle, and from angle A this is the opposite side. Now notice this is not a right triangle, so it's not the hypotenuse, it's just the opposite side. And then next to A I have an adjacent side and an adjacent side. So we use the law of cosines when we have side angle side or side side side. That's what we wrote down last week, and here are the situations. So we have the angle and the two sides are there, so it's the angle in between these two sides. Or I only have sides and I don't have any angles. That's when I need to use law of cosines. This is when we use law of sines, when you had two angles and a side in any order, or side-side angle. So different from this one, the angle is not in between the two sides for here, versus this one, the angle has to be in between the two sides. Let's look at its formula. So the formula is this, where it says you need two adjacent sides and the angle in between, and then this is the formula to find the opposite side. So I'm looking for this side. And we have the opposite squared is equal to the adjacent squared plus the adjacent squared minus 2 times the adjacent times the cosine of theta. Now, one thing I want you to remember is this is all multiplied. So please keep that in mind as you guys go through your calculator. So if you want to use your calculator in one whole thing, then you've got to type in the whole thing with the parentheses and everything in order to use that. So we use the law of sines when we're going to find acute angles. So if we're certain that all the angles are acute, we can use the law of sines. But I can use the law of cosines when I know that it's an obtuse angle. In fact, the law of cosines is the only way to find an obtuse angle. So anytime that you have to work backwards to find an angle, you're going to do the biggest angle first using the law of cosines. Now, what if I'm not looking for the side, but I'm actually looking to find the angle, and I want to work backwards? So that means I want to unbury this. Well, I'm just going to rearrange this formula to make it easier for me to substitute so I can find the cosine of theta. I'm going to subtract the adjacent squared minus this adjacent squared from both sides. And my formula looks like this. So I have the opposite squared minus the adjacent squared minus the adjacent squared, and it equals -2 times the adjacent times the adjacent times the cosine of theta. After that, to get cosine of theta all by itself, since this is multiplied, I need to divide. So I'm going to divide by -2 adjacent times adjacent on both sides. And your equation looks like this. Oops. So your equation looks like this. Now remember, this is the cosine of theta. It's not theta by itself. So the next step is to do the inverse. So theta is going to equal the inverse cosine of whatever decimal you get. So you can't do it until, you can't find theta until after you've done the inverse. So just keep that in mind as we go through this particular thing. Now let's get to our examples. So So here's the first example. We'll do the side, side, side version first.